Good morning and welcome everyone to the 3D Singapore Sandbox session. The 3D Singapore Sandbox is a program we launched in 2020 to encourage the use of 3D geospatial data to develop and test new applications and services. We now invite Wendy Koo from GeoWorks to moderate this session. Over to you, Wendy.
Thank you, Vanessa. Good morning, ladies and gentlemen. Once again, welcome to our webinar. First of all, let me introduce myself. My name is Wendy Koo, and I will be your moderator for this session. Now, please join me in welcoming our guest speakers from Autodesk, Mr. Noah Alice, Technical Specialist Manager for Infrastructure. From S3 Singapore, Mr. Luis Goh, Chief Solution Architect. And from Hexagon, Dr. Uwe Jasnok, VP of Business Development and Director of Pre-Sales for APAC. Before we begin the demo, may we have each of our guest speakers to give a brief introduction of herself. Let's start with you, Noah.
Hey, thanks, Wendy, and I'm glad that you've invited us over to share with our audience technology that's available. A little about myself. I've been with Autodesk for 16 years now, and I'm looking after a group of specialized engineers who look after the AEC industry, which is architecture, engineering, and construction. So we do have team members scattered around the greater Asia Pacific, from ANZ, ASEAN, and India. So I'm just happy to be here, be sharing with you some exciting technology that will enable our audience to work with 3D models a lot more interactively and faster.
And thank you, Noah. And Luis?
Hello, everyone. I'm Luis from S3 Singapore. At S3 Singapore, I'm taking care of the solutions team. And for the solutions team, we do have a special team of consultants that take care of the built environment in the AEC sector. So for us, we work with many stakeholders from government agencies right down to the different developers, constructors, and coming up with, I would say, game-changing solutions for them to be able to manage some of their business challenges, right? So I'm happy to share some of this today with you. Thank you again, Wendy, to SLA for, giving us this opportunity. We appreciate that. Thank you.
Thank you, Luis. Last but not least, Dr. Uwe Jasnok.
Good morning, Wendy, and it's really a great pleasure to be here. I'm now, I guess, something like 16 years with Hexagon, similar to Noah, in different roles. And my personal first touch point with a 3D city model is back to the early 2000s, when I was with the German Research Institute. So we made there the first 3D visualization, of course, in different scale and different quality. But the topic of visualization of a 3D city with all its effects and belongings and how we can optimize the city with the help of visualization is a kind of red rope which goes through my life, through all of my professional career. And I'm very happy to have the chance to share some of the insights we generate at Hexagon with you and the audience. And we are looking forward to a really fruitful discussion, of course.
Thank you, everyone. Yes, and certainly we are very happy to have you with us, being our 3D Sandbox partners. And I understand that you will be sharing with us some wonderful use cases you have for the AEC sector, presenting demos on 3D visualization, shadow impact analysis, as well as visibility study for buildings and more. So we can't wait to have you start with this. Now, before we begin, just a reminder to everyone, we will be taking questions at the end of each panel. And please feel free to post your questions in the Q&A section during the presentation. And now, without further ado, for our first presentation, may we now invite Noah of Autodesk to present how 3D geospatial data can be used to enable effective analytical and optimization planning through a single platform. Over to you now, Noah.
Hey, Wendy, just to check, can you see my screen?
Yes, we can.
All right. So what we're going to go through is a very interactive experience. Now, you might be asking, how come I have the whole of Singapore in this model? Did I create it? The answer is, well, yes and no. Now is a time where we've democratized technology so that we can allow even the most ordinary of users to capture data from the web and combine that with a myriad of different types of data to make the planning and the preliminary design more interactive. You can see here in a quick view of the most common platforms that you can use to enrich this experience and the model that we're looking at. So one of the more common things nowadays is flying drones, right? So by being able to fly a drone, you are able to stitch together a point cloud of an existing structure. So this is one of the fastest ways to gain a better understanding of what the existing project could look like. In this case, we want to make sure and check how maybe a building that looks like this would look like in the context of the existing scenario for this site in Singapore. You can see that by simply capturing photos from drones, you can stitch those together to gain a better understanding on how it would impact this site. Now, to further develop this particular area of interest, what we're going to do here is we're going to sketch some features. Traditionally, this kind of routine was done on paper or in certain cases CAD, but the experience is quite limiting because you're faced with something that's either too rough or either too technical. In this particular example, what we're trying to do here is give users and the different stakeholders a much more visual and interactive experience, thereby giving them the ability to give feedback and understand what the design intent really is. So instead of looking at papers where you have highlighters that represent roads or CADs that are too technical, why not do it in an interactive manner, which allows you to get stakeholder buy-in and streamline the decision-making process faster. So we're going to add a few more features here. In this case, we're going to sketch in literally a road. And I hope that as we do this, you can see that it gives us visual feedback on some of the details, like the length of the roadway, some visual controls like grips. These things allow you to interactively make adjustments, and those adjustments would translate to a better understanding of what that change really is going to be in this site. So this allowed us to quickly sketch 2 roads for our site. If we want to add in, let's say, a building pad, why not sketch one in, okay? And we're doing 3D routines with the simplest of commands. And it shows that 3D technology has evolved into a much more user-friendly experience. You don't have to be an expert in high-end solutions. All you have to have experience around the computer to work with 3D models is a mouse and keyboard. If you have an internet connection, you can bring in different types of data from OpenStreetMap, USGS, and all of the different information that's readily available. So in this particular site grading, we want to employ, let's say, a 3:1 cut and fill, and maybe a retaining wall for the cut portions. So I might be talking in engineering terms, but how does that translate visually? Well, no need to explain technically because everyone in the audience can understand what the building pad is going to look like. Now, BIM has almost been synonymous to Autodesk, and to be specific, Revit. So what we're doing here is we're bringing in a Revit model of our proposed project to see how it performs, to see how it looks like in the context of the existing scenario or the existing site. So you can see that detailed models of Revit can be brought in for a better understanding of what that structure is going to be. And need we say more? You saw that we even have furniture inside of the building. You can bring in highly detailed models or limit it to just the facade, whatever your purpose may be. I think the key takeaway from this particular step is that it doesn't matter what kind of information you have. Now you have an interactive way of combining all of those different types of information to make the planning and preliminary design a very interactive experience. Maybe we want to adjust the orientation of the building for different reasons. Maybe you're after solar gain. Maybe you're after maximizing the experience in terms of the view, right? Since this is by the seaside, maybe you want to explore which experience could be the best for the tenants or the people who are going to use this building. Now that we have this Revit model inside the context of this particular project site, what we want to do is we want to see how this performs maybe in terms of daylight analysis or sun shadow. How do we do that? So in a matter of minutes, by combining different types of information, we can quickly explore how the sun interacts with our project. And whatever you're seeing here are the real geographical or geolocated performance or geolocated sun shadow analysis, because this is in Singapore. The sun interacts with our project quite specifically to this part of Singapore, whatever date or time it may be. All right. So what we're going to try and do next is we're going to try and see if we can tweak the site access by maybe expanding the capacity of the 2-lane road that we just did. Okay. To be able to do that, you can take advantage of existing content that's already inside of the platform, which is InfraWorks. Now, these are the default content, but make no mistake, you can further enrich this by adding readily available 3D information from the web. So what we're going to do here is we're going to focus more on the type of road that we are going to employ for this particular project. So you're looking at something that's out of the box, but again, just like almost everything inside of the platform, you are able to create specific parameters or even create versions of this 3D style to reflect what you need for your project. So by simply dragging and dropping, like what we did for most of the data, you'd be able to get a visual feedback, thereby gaining a better understanding on what that change means for this project. And by changing the roadway to a much more intelligent version of a road, we are able to access preliminary engineering data. And guess what? Just like anything that we've done so far, this is also interactive. If we make adjustments to the profile, if we make adjustments to the cross-section, or anything about the roadway, it will give us feedback on what the effects of that adjustment was. If we want to, let's say, accommodate larger vehicles, drag and drop a specific vehicle into the canvas, and it will reflect that change. Let's go back to accommodating smaller wheelbase vehicles. Maybe what we want to do here is we want to ease the traffic a little bit for this part of the road. So by using visual grips, we can pull this certain grip to create that turning refuge to the left. And you might be wondering, hey, we're in Singapore, so the driving direction is already on the left side. So this talks back to the geolocation of this specific project and the intelligence that it automatically detected that the driving direction in Singapore is on the left. So what we're trying to do here is we're not creating models just for the sake of creating 3D models. What we want to do next is we want to analyze how traffic's going to perform in this particular site. And to do that, maybe you have access to LTA's vehicle volume count for this particular part of Singapore. All you have to do is key those factors in, those parameters in, sync it with your 3D model. And once you're done with all of that number crunching, which in this case, you're not doing the number crunching, you're letting the cloud run that simulation and play that simulation live. Again, guess what? We're not, some of our stakeholders are probably not traffic engineers, but if they get to visualize what the traffic's going to look like, of course, supported by the reports that you can also generate, this makes for a much more pleasant experience in the decision-making process. You get feedback that is substantiated by information that is afforded by the models that we're working with. Now, let's add some other features to our project. Maybe we want to add a bridge. So we're going to do a bit of preliminary engineering. And again, back when people were stuck with 2D, you probably had to do this routine in something that's Civil 3D. Now, Civil 3D is a very powerful platform, but it's quite powerful in the detailed design process, but it doesn't translate much when you want to communicate the design intent. By using this platform, you'll be able to interactively add structures, like in this case, a bridge. structure. So what we did there was by using graphical commands, we were able to specify the beginning and the end of a bridge section. We'll go back to that bridge later on. Maybe we want to manage the surface runoff for rainfall, okay? So for every road that you construct, you'll have to manage the surface runoff by maybe putting in some manholes and drainage pipes. And we're doing that interactively on the screen. And again, in a matter of minutes, we can pretty much understand what other aspects of the project would have to be included before the actual detailed design process. And all of this, again, just like the traffic simulation that you did, can be analyzed so that at an early point in the project, you have a better understanding in terms of costing, in terms of quantities, what those projects are going to look like. Maybe you want to look at underneath Singapore, right? Nowadays, most of the government agencies that we work with now have an underground planning division, because if you want to expand in a place like Singapore, either you build up or you build underneath, right? So with just simple commands, it gives us very visual proposals that are easy to understand, but are also supported by the information that it affords us. Now, I hope that gave you an idea on how easy 3D is to work with nowadays. You don't have to be an expert in any CAD. As long as you have experience in the mouse and with data, you'll get visual feedback, accelerating the decision-making process. That's it for me.
All right, thank you. Thank you, Noah, for a very impressive demonstration. So you mentioned that it's really easy to embark on a journey of using the 3D data. Perhaps you can tell us more about what are some of the key advantages of using 3D data that can be achieved with 2D data, as in your case?
Well, as far as what we've gone through, and if I haven't said it enough during my spill, I think most of the people who are doing the routines that we just did in minutes are struggling to do this in 2D. And they do have access to all of the data, but that being in different platforms is a challenge in itself. And being able to respond, being able to get feedback quickly is of much importance when it comes to making decisions for any project. I don't have to explain that time is money for any AEC project, because time really is money. What we're trying to do here is we're evolving the decision-making process so that you're not only working with 2D, and as we've shown earlier, now is the time, now more than ever, 3D is more accessible, whether from the web or from agencies such as yourself, and creating a 3D interactive experience to convince and accelerate the decision-making process, and not just for the sake of having 3D, but being equipped with the information that's the underpinnings of those 3D models is already at your fingertips, so to speak. So in essence, what we're doing here is we're making the decision-making process faster and more informed with the help of 3D. And you don't have to be an expert, you don't have to be an engineer to gain a better understanding of what the project intent is, because the impact of making decisions is higher at an earlier phase, and that's what we're doing. We're giving you the ability to impact your projects at an earlier phase rather than it being an afterthought.
Great, Noah. And I would like to add on to that you know, the Singapore Sandbox having all those models, and subsequently when we add a bit more layers on top, it will definitely make all this embarking in the journey using 3D data a lot easier as well. Wouldn't you agree with me?
Absolutely.
All right, thank you. Right, coming up next, we have Luis Go from Esri Singapore, who will be demonstrating how 3D geospatial data can enable data visualization for effective analytical and planning, including building shadow analysis and dengue hotspots. Over to you now, Luis.
Thank you, Wendy. Yeah, let me share my screen. Are you able to see my screen?
Not yet.
Okay. How about now? Are you able to see my screen?
Yes, we can now.
All right, thank you so much. All right, good morning. I'm Louis, and on behalf of everyone from S3 Singapore, thank you for joining us today. I'm delighted to have you with us. First, I would like to thank SLA GeoWorks for the opportunity to share our 3D Sandbox showcase. Our topic today is on the use case for AEC sector. I would like to use our 3D Singapore Sandbox to demonstrate how 3D can support AEC use cases. We have partnered with GeoWorks on the wonderful 3D data set of CityGML models for the entire Singapore. We have loaded thousands of buildings, rendered satellite imagery on the building to create the realistic digital twin that you see now. Our platform computes the models and imagery on the fly in real time, as you can see in the demo. So moving over to Sentosa, complex models such as Battlestar Galactica rides in USS can be visualized on our platform. This complex model allows for a realistic understanding of complex land and air space usage with respect to its surrounding. The ability of visualizing a complex model allows for the planning of visitors' movement with regards to the entrances and exits. This ensures proper crowd movement for safety and security. Our sandbox is highly interoperable and allows you to bring in your own data set to overlay your business information to contextualize the 3D sandbox to your business needs. Our platform runs on open standards to integrate and bring in a wide variety of data sources to enrich your digital twin. Data such as base maps, digital terrain, building beam, infrastructure models, and business data can be harmonized on a single platform in 3D. Here we have a 3D map to visualize dengue outbreaks. This allows us to understand the importance of locations to spot trends and activities of dengue patterns. A separate layer of Zirca map can be overlaid to spot commonalities of potential breeding grounds and to make important decisions on what is the area to cover, where to fog, and how many resources are required. Our 3D platform recreates important building structures, such as St. Andrew's Cathedral. Visualizing the location of the cathedral allows a user to understand the location, orientation, and appreciate the beauty of the building to its surrounding. Importantly, from an AEC point of view, our spatial analytics tools allows users to take accurate measurements of the cathedral. In this example, you can see the height of the building that is being measured. This allows for easy retrieval of information from a model. The land area of the cathedral can also be measured as well, allowing users to size up the land use space for this structure, as you can see in this demo. Our 3D sandbox allows you to perform a variety of 3D tasks and analysis, such as visibility, shadow impact, solar potential, and flood impact analysis. Visibility analysis increases the aesthetic values of the building design and allows us to determine vantage points from within the building. The line of sight analysis allows developers to design and build buildings that are a seamless fit to its surrounding. Viewpoint analysis provides better understanding of the aesthetic value of each unit and floor, which then can translate to different pricing models to optimize revenue for developers. Shadow impact analysis allows us to understand the shadow impact of the surrounding buildings and infrastructure to design a building that fits harmoniously into the surrounding. As you can see on this model, the shadow of MediaCorp building was analyzed during the design phase of the Alice project, which will be here. We were able to create the shadow of the MediaCorp building, analyze the impact, and design it to be away from the shadow. This not only allows proper sun exposure for Alice inhabitants and promotes the use of sunlight as the main form of light energy, thus reducing electrical energy consumption to go green. Last but not least, in facilities management, I would like to highlight that GIS is highly applicable in the life cycle of facilities management. Throughout the stages of plan, design, construction, operations, and maintenance, GIS contextualizes the space that needs to be managed and provides intuitive understanding of the space as shown in the different types of units in the Commonwealth Tower. The unit types, layout, proximity, availability, and pricing of the units are visualized on the 3D model for a more insightful and impactful understanding of the current business operations and performance. This improves the business understanding and allows business to make critical business decisions. So I've come to the end of the demonstration. Thank you for your time, and I hope that you have found this session useful. And if you have any questions, please feel free to raise them. I'll be happy to answer them. We can have more detailed discussions on how we can help AEC leverage on 3D technology to improve your business. Thank you.
Thank you, Louis. Let's see, we have questions. Yeah, I do have some questions for you, Louis. So what do you think are the key features of 3D data to enable building shadow analysis that you have just shown us?
Okay, so for 3D data, I think the richness of 3D data is very different from the 2D maps that we are used to handle today. With 3D, we actually get the context of height dimension. And with this height dimension, it puts a lot more perspective into the model or digital twin that we are looking at today. With this height dimension, right, a lot of things that usually has to be flat when visualized now has the realism of 3 dimension. And it really adds to the effect of the digital twin that we talk about. So using the height dimension, visualizing things like line visibility analysis, shadow analysis, this allows this analysis to be done in a more realistic manner. And this allows us to gather a lot more impact, a lot more analysis from such features from the platform. So from that point of view, we can imagine that the platform allows a user to get really realistic understanding information to make better business decisions here.
Thank you, Louis. Right. Any questions from the audience? All right. If not, then perhaps coming up next, we will have Hexagon, Dr. Uwe Jasnok, to present your demonstration of using 3D Singapore Sandbox as digital twin. Over to you now, Uwe.
Thanks, Wendy. I guess you're going to see my slides. Thank you very much for GeoWorks for letting us participating in the 3D Sandbox, of course. And I'm really glad to be the last in the row because the colleagues, Noah and Luis, already touched a lot of points which are important. And so I'm going to try to bring additional aspects to enhance what the colleagues already said. We from Hexagon, we are putting the 3D Sandbox of Singapore in the context of a digital twin. And the reason why we're going to do that is it's very simplified. A digital twin is just more than a pure 3D model because it also helps as a common platform for all the different stakeholders of a city to bring in the data, to fuse the data, to break up the silos, the data silos, and do this in an appropriate spatial manner with 3D visualization. And the digital twin, in this case, of course, we do have multiple digital twins. When we talk about the 3D Sandbox, it's a digital twin for an urban environment. So we call it also urban digital twin. Now, with the ability of adding additional sensor data, we're going to enhance the sandbox in terms of dynamics. Now, when we talk about the AEC sector, in principle, we need to really distinguish a couple of different phases. So the colleagues were showing excellent elements in the pre-phase or in the planning phase by placing new buildings into the 3D sandbox, by doing the environmental impact studies like lightning, what is the effect in terms of solar energy, and so on. But we can and have to go further with the 3D sandbox concept. And this was already partially addressed by Noah from Autodesk, this ability of putting in data which comes from drones and of course scanners. By that, we can also monitor and enhance the 3D sandbox concept during the construction phase, not only when it comes to the point when a building is already built up, also during the construction phase, we can utilize different forms of scanners to monitor the progress over the time, to see the impact of the construction site in the context of the city, like traffic jams which it may cause. And finally, we have also to think about the post phase. So after the construction is done, we need to justify, verify, for example, if the building, if the bridge, if the street was built as designed. And also here the 3D sandbox / digital twin is going to help us. Now, as the colleagues already pointed out, the 3D sandbox is just more than 3D. We are really helping, and all the different presentations indicates this. We really bring more clarity and reality into the game. So by, for example, doing a line of sight analytics, which is very important. For example, also when we're going to plan 5G, we do need to have the reflections of the building. We need to have a beautiful 3D model, also a digital elevation model. If you're going to do the flood analytics, we need to bring in the points and see clearly in real time what are the effects of certain simulations in noise distribution. What happens if I'm going to bring in a new noise protection wall? What is the positive impact for the residents in this area? And this means that the 3D sandbox is really providing an excellent frame for visualizing all different means of simulations and the impact in our daily life. And you do need to have different views and navigation possibilities. A point which I want to highlight and stress, which is also 3D sandbox, even it doesn't look 3D. When I was talking about putting and linking this to real-time information, to sensor information, what we have done in this version of the 3D sandbox is linking the traffic information of Singapore to the 3D sandbox data in 2D, but for traffic it's good enough. Then we add on all the different construction sites. We link these construction sites with the planning, and then we're going to see how the construction has an influence on the flow of the traffic, what is going to hinder, what is the effect, where is this flow going to propagate through the city, what are the alternative routes the traffic people are looking at. But the principle, and it really doesn't matter if it's a 2D, 3D element, is that the ability of the sandbox gives us the right context, the right data source, which brings the possibility of fuse all the different data together. Now, saying that, this is, so to say, the bright side of life, but all of those topics do have also a kind of downside sometimes. And these downsides are challenges we need to address. And one of the very most important element for each sandbox, for each digital twin is what are the processes to keep data actual? Now, it's really lovely to have this 3D sandbox as is, but we do need to establish all the procedures to keep the data actual. Now we can argue like, oh, that's exactly the topic of BIM. Yes, to a certain degree. But we have also to accept that not everything is always planned with BIM, even if we would like to have it. And second, we need, as I said, we need to make sure that as BIM is only addressing the planning stage, we need to make sure that this is also working in the post phase, means where we need to validate and verify if the buildings are, or the constructions are really built as designed. A second point is really that we need to validate the data. If you're going to look to the screenshot, we have highlighted 2 buildings, and as you can estimate out of the screenshot, you would say that these buildings are quite equal in height. The reality is that the left tower has 26 floors more than the right tower, but you can't see it. And obviously, we do have here a small mistake in the building. And the only indicator you have is if you're really looking very closely to the textures of the left building, you see that the levels are much more tiny than on the right one. However, it pinpoints to some problem. It's good that we have the data, but we need also to have procedures on validating the data so that the data which is available is really reflecting the actual state, because obviously a building which has 26 floors in height gives a different shadow than if it would be lower. Now, also, what we want to stress is that we need to think more in terms of future sustainability and efficiency. Means that we need to really promote these 3D sandbox, these digital twin, to more city domains in order to really have them a better analytics of the impacts of the planning on how to convert to a green city. And therefore, we do need to address more topics concerning electricity, not only the solar panels, also the consumption of electricity. In terms of water, the colleague from Esri was talking about flooding. Yes, of course, this is a really important topic, especially in the rainy season. Nevertheless, we do need to talk also about water on a regular basis, means fresh water and wastewater. We need to really import these simulations on temperature and how the plants in the inner city is helping us to make it more comfortable, to lower the temperature. And of course, one of the most important elements we see is also that we need to provide the 3D sandbox with accurate data. And here accuracy is really the key to our colleagues from emergency services, which help protect our life. Now, to summarize, we believe that the digital twin and the 3D sandbox helps us creating more accurate representations of our world, which provides at the end the basis for a better monitoring of the context, which optimize our safety, which optimize processes. And last but not least, and that's always the ultimate goal, it turns information into insights. In the AEC sector, when we start from planning during execution to the post phase where we're going to validate if everything was executed as planned, and also to adjacent markets where the 3D sandbox gives us really an additional insight, a platform for data fusion. So thank you for listening, and I'm happy to answer questions.
Thank you, Wolver, for a very impressive presentation. So a question for me, in your presentation, you address the challenge of keeping the data actual or accurate. What do you see as an approach to overcome that challenge?
Well, actually, we do have, when we need to update the data, we can, of course, go the manual way by entering BIM models, making on-site surveys, and. But this is really not the key of doing something. We need to automate the process. That means we need to fully automate the process from data acquisition to transforming it into a 3D model with all respective attributes and update the corresponding 3D sandbox part. And we can do this on small scale with buildings and with UAVs, as Noah was showing in his presentation. But we also need to do in regular manner it on a large scale. Means we need to take airborne sensors, fly over Singapore and reset the initial frame so that on an incremental way we can update the models with the new stuff. But this whole process needs to be as automatic as possible, because otherwise we are going to be lost in human work, which is not the key. And then the value of the 3D sandbox is gone.
All right, thank you. So when you utilize the 3D Singapore data, what will you pick as the most important thing, in building your digital twin?
Yeah, I think the most important thing is really the possibility, aside from the AEC sector, of course, is really that it provides a platform for data fusion, where all the different departments of the city admin can bring in their data. They will get a different view on their data because it's shown in 2D, 3D in the context. And our experience with working with digital twins and Sandbox is really that this helps really a lot the city admins to take better decisions, because they do not only focus on their own silo, they see the impact they have on the other departments. So this ability of creating insights is, for me, really the most important aspect that every sandbox has.
Great. Yeah, so thank you once again, Uwe. Let's see, we have any questions from the audience. Do feel free to post the questions there. Maybe just to continue the conversation, for any one of you to attend, to share with us, in terms of embarking on the journey of 3D, sandbox, and especially when you are partners using our GeoWorks sandbox, what are some of the, I would say, benefits that came out of it, really through the learning cycle, and also some of the challenges you feel that, we have to work together to overcome those? Anyone, perhaps Noah or Uwe?
Wendy was gauging. Could you repeat the question? You mentioned something about challenges in the sandbox.
Wendy,
yes. Yeah. Yes. No, so I was just, just to share, because you are the partners of a 3D sandbox. So just to share, your experience of using our sandbox, and some of the ease of using it as well, to help you build, and where else you think you can build on top, additionally, to enhance that features.
Yeah, I'll go on ahead. I think when we were doing we were working with you since the beginning of GeoWorks, and I found it interesting that we were trying to find what works in the context of a display that could be interactive to anyone who attended. So whatever we put up on our part in the sense of the sandbox is something that needs no customization. We want to make sure that users can enjoy whatever benefits of working in 3D in the sandbox experience in SLA office, whether it's from there or it's via a download as a trial from the web. So when we were working at the earlier phase of Sandbox, that was our guiding principle. We want to make sure that we democratize the technology so that you don't have to be an expert to use 3D. The data, most of it is already there. And when we started the first few versions of the Singapore model, everything was just straight from the web. And we were able to use what SLA also provided us as models to enrich the experience. So it just becomes richer, more so if the user realize that, hey, I'm doing this, I can do this, right? So that's what we want to give the users, that confidence of starting that first step in using 3D in their work.
Thank you, Noah. I agree. I think there were a lot of, though there were a lot of, inquiry and interest in 3D, but I think there will be a level of doubt, some on embarking on this journey, right? Implementing. A lot of people think that you need to have a certain expertise, to be able to start on this journey. Especially for TwinTalk, digital twin, maybe Uwe can speak a lot. How easy is it to jump into this? I mean, I wouldn't say it's easy, but what are the steps to getting it right?
Well, I'm not sure if I'm the one who should judge on what is the step to doing it right. But what I can say is that first of all, and the experience was quite similar to the one Noah gave and shared with us. It was really easy to work with the data. It was really easy to see the progress. And for me, the most important part, I have to say, it was when I was talking to my staff members in Singapore, when they were in contact with the 3D Sandbox, they generated their ideas by themselves. And they said, hey, Uwe, look, we can use it for this, and we can add this topic to that, and we can do this, include this simulation. So I think for us, it was really very inspiring working with the 3D Sandbox because we do have an excellent playground to probe and test and see things, not only for us. When the colleagues are living obviously in Singapore, so they play for themselves as a resident. So and they by themselves get inspired of using things in 3D and 2D. Now you can argue, for us 3D is nothing new. Of course, we work with 3D and all different means all over the time, but it's definitely a different feeling if you do it in the area where you're living at. And you will always have the same elements. The first thing, everyone who gets in contact either in 2D or 3D information with Geo, he first looks where I'm living. So show me my building, show me where my flat is, show me whatever, show me the surroundings. And you directly get the probe on, this small little grocery shop is not longer there. We need to update the data and these things. So there's a couple of effects you're going to see. But again, I truly believe, and this is really my baseline of these things. We have two elements which are of highest importance. Really, one is make sure that the data is actual, up to date, and accurate. Because if this is not given, all the stuff we do, it doesn't matter what kind of simulation we run, it doesn't matter what kind of service we utilize with that, is wrong, because the basis is wrong. So this up-to-date information is really the key from my perspective. And the second one is really that we really be to include all different kind of simulations, because the 3D gives us ability of running simulations. We were dreaming years ago where we said, we do need mainframes, whatever, in the old days, which can't be run. And we are now having things on the fingertip. Just 10 years ago, this shadowing simulation was not on the fingertips like you can show today. Now, flooding simulation comes closer to get on your fingertips. And these are the elements we need to think of. And again, every time I was in Singapore, I see the traffic, and of course, we can see it and we can feel it in our daily life. So linking and fusing real-time information to influence the simulation and the modeling and probe it against reality is one of the key elements where I see a huge value for the sandbox. Luis, over to you.
I think back to the data question, I think first of all, we definitely appreciate the amount of data and the quality of data that SLA has shared with us. That can be seen in the demo of how we can, visualize that and to create the realistic perspective of things. Of course, kudos to SLA to really build up that kind of quality of data. I think that's extremely important. I think the other value that GeoWorks bring to us is really being able to put out put the partners, us, together, right, as a platform to showcase to other businesses, agencies, organizations. And I think that is really something that it's not only just an industry engagement, it's something that we hope to be able to use this technology to help to transform the industry, right, to embark on technologies that will really help them moving forward, right? I think in the traditional use cases of construction, there's a lot of different interpretation, different sources of data, silo information. And, what could be a better way than to have a single view, right? Single source of truth, putting all these various forms of data together, communicating to all these stakeholders. It's not only between the different business partners, it's also between the businesses to the government agencies. I think this by itself brings a lot of value here. Thank you.
Thank you, Louis. In fact, I was actually very intrigued with the building shadow analysis, the simulation that you did, and what Uwe has also mentioned. Would it be possible with a 2D data? Or is it something that could only be done with the 3D model or 3D data?
Okay, maybe I'll just take a quick one on this. So on shadow analysis, I think the height is something that is going to be very important, right? So 2D data probably will not be enough, but of course we can always extrapolate the 2D data, right? So that we can create massing models to create the shadow analysis that we can use, right? So that would be the quick answer.
Yeah, but with that, go ahead. Yes, Uwe.
Oh, I'm sorry. Yeah, I just wanted to really support Louis. At the end, the computation don't need a 3D visualization, but in terms of communicating the results, 3D is vital. That's a difference. But for the computation itself, no one cares about that.
Right. But the visualization definitely helps when you see where the shadow is impacting, right? If we have all these layers on top of it, the hydro layers and everything else, it speaks a lot more than what, a data can tell you. So yeah. Yes, we do.
For us humans, it's really helpful.
Okay. Yes, we have a question from Fujiri. As 3 different companies, what is the best way to enable cross-platform compatibility of the sandboxes? This seems quite important to achieve a single source of truth eventually. Very good question. So perhaps we can have any one of you or each of you to give your thought on this.
I'll take a stab at it. Yeah, so I think for starters, it's important to know that all of this is also part of Building Smart, which we're one of the co-founders, and the intent there really is to be able to open up our technology so that we are able to work with different types of applications and even developers. We've seen an increase of development work that's being done from large third-party organizations to small startups being able to develop various kinds of applications on our technology. So that's one of the biggest strategies that we've implemented to make sure that our technology is open enough so that anyone who has access to the APIs can develop on our technology. So apart from Building Smart, which is among other efforts, being able to maintain open technology and giving access to API. Again, I'm going to go back to my favorite catchphrase, democratizing the technology really makes it easier for us to work with a myriad of users, whether it's for a very specific purpose that's just for Singapore or for something that's very common, just like sun shadow analysis.
Well, actually, maybe we should ask this to GeoWorks because they make it happen. We already showed that it works, so we should ask them what was their plan to achieve this, because at the end they gave us the guidelines and the data formats which enabled us to do so. And I think we all showed, Louis, Noah, and myself showed that it's already achieved.
Yes, thank you. But yes, indeed, the question back to, or rather the answer back to Ray here from HSC pipeline engineering. So yes, the Sandbox is actually seeks to provide that interoperability for people to just use it sort of an out-of-box solution as well. Happy to follow up with you after this session if you'd like to find out more. We do have another question. Yes. And this is from Lim Kim Cheong, consultants. So any underground building info included in the digital twins model? What are the difficulties faced? So I think this question is for Uwe.
Well, actually, yes, of course, you can, of course, enter underground information. We do have models from the underground of Singapore enhanced to the 3D sandbox, for example. The difficulties is typically, when you navigate in a regular 3D model, you typically try to prevent to go underground because you screw up the visualization. Now, there's no technical barrier; it's more like a visual barrier. If you dive under, you do have a different view, which is really confusing. And as Noah showed, you need to have really good methods of helping to see and identify underground structures. And we are experimenting also with a lot of different views, like we're taking the model from top, and then we have a technology implemented which helps us to make a virtual dig into the model to show the underground structure from top to bottom, not from bottom to top. So it's really more. It's not a technical issue. It's more like the question on how to visualize in a way which is very natural to humans, so that he can understand the spatial dependency of the underground in the context. I'm seeing my colleagues are agreeing to that statement.
Yeah, I mean, I agree heavily with you, especially the last bit, because it's not really difficult. I think your guidance should be the purpose that you would want for 3D models, not because you can 3D it is you're just gonna go ahead and be trigger happy with 3D. Your guidance should be the end in mind, the purpose. And I've seen customers who really are very enthusiastic in modeling in 3D, and they've modeled more than what is necessary at times. So that's why there was, I think one of the more important emerging trends back then was the creation of a BIM execution plan, which dictates the level of detail that has to be delivered, which is fit for purpose. So that's where I think being able to work with 3D goes hand in hand with guidelines or an implementation plan that really dictates whether you should deliver something at a specific level of detail. And different agencies in Singapore in particular I'm starting to see that being implemented. BCA, LTA has their own, and I'm sure SLA also has a bare minimum as far as the kind of details and information that has to be in submittals or information or models, right?
Right. Any last input from Louis?
I don't have much inputs on that. But I guess 3D has come a long way, right? If you compare that against 10, 20 years ago, 3D has transformed so much more. Back then computers were having difficulties trying to process, hundreds of polygons. Today, we are processing millions of polygons in seconds and so on, right? So 3D has come a long way. A lot of technical difficulties and challenges have been ironed out, right? I would say the next step, right? I guess it's really the data collection. That's one thing, right? Because things like underground, it's not going to be easy to collect some of these data points. Then after collection of data points, using different technologies, and how do you reconcile those on the platform? So those are the different gaps that will come into play when anyone wants to deploy 3D technology. But I guess, today, in today's context, 3D is ready for use. It's really fit for use today. And I think that would really help any organization, any clients, to be able to better organize their information in real time, right? And no longer we have to live in the days where data just exists in table forms or in picture forms, right? So that is the exciting things that we are living. This is the exciting times that we are living in today.
Well, thank you. And thank you for a very good question from Lim Kim Pyong. So just make sure we've covered, one more question. Shall we take a stab at the last question? I'm sorry, we don't have time, but we definitely want to follow up with this question from, with this one from Telco. Let's follow up with you on this one. Apologize. We have now come to the end of our webinar. Thank you once again, Noah, Louis, and Dr. Wu for your time. Really wonderful presentation they've given us today. And thank you everybody for attending. We hope you have learned and enjoyed this session. And do join us for our next segment, which is exactly now at 12 p.m. Applying GIS in Engineering Projects by Mark McDonald's. So yes, please, we'll see you very, very soon. Thank you again, everyone, and have a nice day.
Thank you.
Thank you.
Bye-bye.
It was our pleasure.
Bye.
Bye-bye.